Hey guys, this is Yanni from Trilion Quality Systems, and in today's training video, we're going to be going over Argus to Argus comparisons. So as an introduction to this, the point of doing an Argus and Argus comparison is to compare the Argus results from the previous measurement to the current measurement. For example, you can compare the principal strains of the previous results to the current to track how things are changing. From hit to hit, from run to run. You can keep track of your tool changes throughout the life of the tool and provide complete feedback to your tool makers and quality department. This is a big one for doing so and understanding what the whole part is doing, if any variable changes like your die recipe, if there's any wear and tear on the tool, things like that. The prerequisites for something like this, we're going to be using SView, so everything has to be done in SView. You have to export each strain semantic separately to be compared to the baseline for reference measurement, including major strain, minor strain, and thickness reduction. And then you're going to use the current SView measurement once it's created to basically import that data. So why don't we jump into that and see how it's done. Okay, so I'm in my SView here. I have the SView project here open. I'm going to go File, Open. Usually I would pick an Argus project here. In this case, I already have one created. So I'm going to go into my training videos and I'm going to pick the baseline suspension arm. This is going to be my zero reference, my golden part that I want to compare everything to. So you'll see I have an SView file here. I'm just going to open it and you'll see that the part comes up here. In this case, I have the blank, the theoretical blank, the blank, and then the actual form part. In this case, I just want to take the actual form part and export this data. So you'll notice here at the top of the screen, I have selected major strain. So the first thing I want to do from this measurement is I want to export this strain semantic. And like I mentioned before in the prerequisites, we have to do each one individually as individual comparisons to do that. So I'm going to leave everything in technical strain up here in the right-hand corner. I want to leave it engineering because that makes more sense to you as you're working on the shop floor. You don't have to change anything as we did in the previous training video for simulation comparison to Argus, things like that. So in this case, I'm just going to leave everything the way it is, and I'm just going to go to File, and I'm going to go Export, and I'm going to come down to the bottom here where it says Dyna In. This is going to export a version of this file in an FEA type format, which is going to take all the nodes, all the values from the major strain with this export. So you'll see it's going to take me into my current job directory, which in this case is my baseline suspension arm. And to follow the same rule that we normally do in our Argus trainings, I'm going to put everything in my results folder of that specific job. So I'm going to double click on the results folder and I'm just going to call it here major strain. And I'm just going to call it baseline. Or you can call it baseline and then major strain. Just something easy to understand. It really doesn't matter how you name it. And I'm going to hit save. And I'm going to repeat the same process with the other strain semantics. So I'm going to go to minor strain, file, export, Dyna In, and I'm just going to call it minor strain. And hit save, and then the same thing with the thickness reduction. So file, export, Dyna In. Thickness reduction, baseline, and hit save. So now that I have all of the data from this particular part, I can actually close this out and then open the current model. Now, as a point of reference here, you as the operator have full control. If you know that you created the baseline model at the time of, when you shot it, you can go ahead and export all these semantics at that time. So they're just waiting for you in the results folder before you even shoot the next panel. So when you do shoot the next panel, like in a week, a month, a year, whatever, those baselines or those semantics are waiting for you as an FEA type format, so you can just import them as opposed to hunting it down again and trying to open it and export things like that. For the case of this training, you'll see that I just created it. So I'm going to go open the current model, and I'm going to go File, Open. I'm going to go back to my training videos. You'll see the current suspension arm, and I'm going to open that current suspension arm. I've already created the SV file. Now, in this case, I will mention that the results are pretty much the same. So when you see the alignment, they might be a little bit more exact than what you'd see from a part to part, over time. This is a training thing, but so you'll see the steps that you have to do to get this correct. So right here, I have the major strain. It's in a different position. You'll notice it was oriented differently in part space, which is typical because obviously with ARGUS you shoot on a table. It's not on a fixture. So you do have to do an alignment like you did the FEA in that training video. So it follows the same rules. The difference is that you are creating the FEA or the strain semantic from the reference part. So right here that I have this part here open, I'm just going to go ahead and do a file and import, and I'm going to import the FEA data just like you normally would. As we talked about in the FEA training video, before you would have to maybe invert the normals. You do not have to do that with this because you're typically shooting the same side of the part that you did before for the baseline. So I'm just going to hit this white arrow, and I'm going to navigate to my baseline folder here in the results, and I'm going to bring in the major strain baseline data set and hit OK. And just like in the FEA training video, you'll see that we have the FEA data, we have the current measurement. They're not sitting in the same position. Typical, that's what we should expect. So what you want to do now is you want to align the two data sets. You can always rename your FEA data set or your CAD data just like you did in the FEA training video. You don't have to if you give it just a short enough name. If you just say major strain baseline, it's pretty short, it's pretty simple. In this case, I'm going to jump right into the alignment. So I'm just going to go ahead and do a project registration manual pre-registration. And again, now we're literally right back at the beginning of our FEA training video. So we're going to pick a point at the top and a point at the bottom to do the manual pre-registration, which is typically only to get it close. You're not trying to get it 100%, you're just trying to get it close to the position. So I'm going to zoom into the top one, control and click on the point there. Come to the bottom one, do the same thing, control and click here. I'm going to zoom out. You want at least 3 points, just like you did with the FEA comparison video. So we're going to come in here and say control click here, and I'm going to do a control click here. And I will jump over here on this side of the leg and do a similar pick and say control click and control click. So you'll see now after the 3 points, it's given me, I'm roughly almost 6 mils, just under 6 mils aligned. So I'm going to hit apply and close. And now you'll see that they're sitting pretty close to each other. Close is good. Now we want to get it to, we want to bring it home. So we're going to do, again, go to project at the top of the screen here. And you want to go to registration and then best fit registration. Here, again, as the operator, you have full control over what you're going to align the part to. I'm going to actually use the 3 areas here, this top leg, this lower left leg, and the lower right leg. So I'm going to right click, select through surface, draw a box around the top half, right click to select, right click, select on surface again, and repeat the process, draw a box on the lower leg, and right click again and select on surface and pick the other leg on the right side, and then hit preview. So you'll notice here again, like I mentioned, the alignment is going to be pretty much exact, only because the 2 parts that I'm using are pretty much the same file. I just reoriented and spaced myself for the sake of doing the alignment method. But you'll see here it's pretty much 0. You'll never get this close on your part. There's always a deviation there. That's not a bad thing. It's just there always will be a difference. But here I'm going to hit apply and I'm going to hit close. So now you'll notice that since they are aligned, I can hit a right click and deselect all, so everything is sitting right on top of each other. I can turn off the CAD data because everything from here on in is a menu-based selection. So just like in the CAD FEA module, we want to do the same thing that we did before. We aligned it. Now we want to do a comparison to CAD, which is the deviation for the alignment itself in a straight dimensional aspect. Then we're going to map the nodes onto the current ARGUS data set. so we can do the comparison, and then we'll do the comparison. So from here on in, everything is the same from the FEA comparison. So we're going to go to the top here, CAD FEA. Actually, let's go back into the major strain here, and we'll go CAD FEA. We're going to go to Edit FEA Data. We're going to make sure that the unit is the same, which is just a percent sign. We're going to hit Apply and Close. Now we can actually do the CAD FEA to do the compute deviation to CAD. And you'll notice here, if you expand this out, it's saying that we're going to use this baseline FEA, or the Dyna model, which is your previous, your golden part, your zero reference, and create something that's called distance to major strain baseline. It's exactly what you want. We're going to hit OK. And you'll notice that the color change on the part here, and you'll notice that the color tensor on the right is also, the bell curve has changed because now the strain semantic has been created distance to major strain baseline. And that's what we want. This is a dimensional measurement, so pretty much you're sitting at 0. Once you have that, now you want to go ahead and say, I want to go to CAD FEA. I want to map the FEA data set, which is taking the golden part, the zero reference part data, and mapping it onto the current ARGUS part, which is just using it as a blank canvas, as I've always stated in training. Now you can actually change the name of this. I'm going to leave it the same, major strain baseline, and we're looking at the major strain of that. So I'm going to hit OK. So you'll notice now that the part color changes again. It's showing a percentage because we did do the edit FEA data set and gave it the unit, which was the percent. And you'll notice again, if you hit the down arrow on the strain semantic, we now have the major strain baseline, major strain. It's telling you that you created a major strain semantic of the baseline, which is great. Now that you have this, you can then now do the comparison of the major strain of the current part to the major strain of the baseline or the reference part. So we're going to go to CAD FEA, compute deviation to CAD, or I'm sorry, to 3D data set. The basic data set will always be your current model. This is the way I like to do it. It makes things a little bit easier. You want to subtract out that zero reference panel, the baseline. You want to subtract it out. The reason I say this, and this is really important to understand how you're doing it, because if you don't understand what is high and low, which one was subtracted out, you might tell your tool makers to fix the part the wrong way. So when we do this comparison, now this is going to be pretty much 0, but whatever you see, understand that you subtracted out the reference panel. So the current part might sit higher or lower depending on that. So if we expand this out, you'll see that it says the difference between the major strain and the major strain baseline major strain, which is what we're doing. We're subtracting it out. I'm going to hit OK. You'll notice how everything is green because everything, again, in this part is pretty much I compared itself to itself. When you see the part that you're doing, you're going to see some deviations here. And if you zoom in, for example, on this corner, this is a prime example of understanding what was subtracted out. So in this case, this is telling me that the current part, today's part that you shot in this red area, if I follow this strain semantic on the right, is roughly 2.5% more strain than the reference panel. So it's really important to understand that in this red area, and in the blue area, it has less strain. It has 2.5 or 2% less strain than the reference panel. So you want to understand which direction everything is going. So you've seen the comparison that I've done between the major strain of the current and the major strain of the baseline. Now, if you remember at the beginning of this training video, we exported the other strain semantics the same way. We want to import those individually and do the comparisons exactly how we did the major strain. The only difference is that everything else will be already aligned because you did it once for the major strain. So let's see how that works. If I go to File, Import, FEA Dataset, hit the white arrow, I'm going to pick the minor strain. When this comes in, notice it'll be listed here, but it's already been aligned on your screen. So all you need to do is come in here and say right-click, CAD FEA, edit FEA data, and give it a unit, just like we did before, which is the percent because it's in technical. Hit OK, and now you can do the same exact things. You can actually skip the compute deviation to CAD because you know how close the alignment was. You can go straight to the mapping and then the computation to 3D data set. So if I map this, you'll notice that the computer already creates its own semantic. It's using the minor strain to make sure you're selecting the right reference CAD, because it might actually pick the wrong one again. So make sure you're on minor strain this time. It automatically names it down here to say minor strain baseline, minor strain. I'm going to hit OK. You'll notice the color change. I can turn it off on the lower left side here. You'll notice the color change. It has a unit, and now I can do the computation of the two. So I want to subtract here. Notice how I have to select it here now. I want to subtract out the basic data set, which is the minor strain of the current model. I want to subtract out the minor strain of the baseline. It automatically names it. Just hit OK. And you'll notice here it's also green. There's no differences here because again, same part, things like that. You're going to see a difference on your parts, but this is the workflow. And now I'm going to repeat this entire step again with the thickness reduction. So File, Import, FEA Data, hit the white arrow, navigate to where you place your files. I'm going to go Thickness Reduction Baseline, hit OK. You're going to see it come in here. The alignment is already there. I can turn it off, right click, go to CAD FEA, edit the FEA data so I can put the unit in, which is again a %, hit apply, hit close, and then go ahead and do a map. And again, I just want to make sure that it's selecting the right data set, which is the reference is the thickness reduction baseline. It gives it a name already. I'm going to hit OK. It shows me the nodes from the baseline mapped onto the ARGUS real estate. And now I want to compute the deviation of the two. So again, I'm going to pick I want to use the thickness reduction of the current model, subtract out the thickness reduction of the baseline. It automatically names it. I'm going to hit OK. And you'll notice that here is the comparison. So what you're looking at here now are the differences. You have the three differences here. You have difference of major strain, difference of minor strain, and difference of thickness reduction as it relates to the previous or the zero reference baseline golden panel. And you can track this for every hit and keep this as a metric and then do the reporting just like you normally would. So that was how to do an Argus to Argus comparison and how to keep track of the metric. Stay tuned for more videos. We do appreciate you tuning in. Please subscribe if you haven't already to our YouTube channel. I look forward to seeing you guys here in the near future. Thanks. Have a good one.